Hello friend. So today this is our first lecture on linear algebra, and in linear algebra first of all we want to discuss about the matrix and its properties, and the topics are matrix and determinant, system of linear equation, vector space and subspace, linear transformation, eigenvalue, eigenvector, diagonalizability, binary transformation, quadratic equation, and inner product. These all the topic I'll covered in linear algebra, but today our first topic will be matrix and determinant. So let's start. And this uh, this is for CSNet and ITSM examination. You can, if you are preparing for this kind of exam, then you can follow my channel. And since this is my first video, so this is my humble request to you that please for like and subscribe, and let's ready. First of all, matrix. you know Before giving the definition of matrix, I want to give an example. And if I give you an example of matrix, then you can understand properly that what is actually this mean. And since it's the it's for sales and examination, so obviously you already passed BSc and also higher secondary, and matrix is covered in that classes, so that's why you know the basic of the matrix. So I'll cover all of this, but so fastly, because I think it's very much easy in linear algebra, and in next topic it will be hard. Okay, so first of all, construct a matrix of order 3 cross 3. This is called the order of the matrix, where aij is equal to I plus j by 2 and or I minus j whole square. Now what is the meaning of I and j? It's mean that now you can see here a11. This means this is this for first one it is the row, and for second one is the column. That means first row, first column. And similarly, it is a12. This means this is first row and second column. This is 1 3, first row, third column. A21, so second row, first column. A33, third row, third column. This is the meaning of I and j, and I represent the first and j represent the second. Okay, now here says that I plus j by 2. Here I1 j2 j1, sorry. So 1 plus 1 is 2 divided by 2, that means 1. So the value of a11 is 1. Also I is 1, j is 2, so that's why I plus j by 2 means 2 plus 1, that means 3 by 2. 3 by 2 means 1.5. 1 plus 3, 4 by 2, 2. Similarly 2 plus 1, 3 by 2, 1.5. Then these all the result you can easily understand that what happened actually, and our actual result is this. Similarly, B matrix is coming from this result, that means I minus j square. Here B is equal to 0 1 4 1 0 1 4 0 1. How it's coming? Now for the first position, 1 1 1 minus 1 0 0 square is 0. 1 minus 2 minus 1 minus 1 square is 1. 1 minus 3 2 2 square is 4. Okay, so this is our actual result. Next, here basic of order means if a matrix have 3 row and 3 column, it's called 3 cross 3 matrix. If have n row n column, then it's called n cross n matrix. Here you can see for this example, here's 2 row and 3 column, so 2 cross 3 matrix. This is the order of the matrix. Here 2 cross 2 matrix. Okay, and here is an example that, okay, Now some properties. First of all, addition and subtraction. For addition, if you want to add two matrix, then it's necessary that their order will be same. Means it is 3 cos 2 matrix and it is 2 cos 2 matrix, so a plus b is not possible. Understand? If you want to actually add two matrices, then it's must be important that their order will be same. And here C is A, B, C, D, E, F. Here A is 1, 2, 3, 4, 5, 6. Now their order is 2 cos 3 and 2 cos 3. So the addition will be possible. So A plus C is possible. And here you can say that how can add two numbers? It's very much easy. First term add with first term, that is 1 plus A is here. Second term with second term, that is 2b 2 plus b, 3 and c 3 plus c, 4 and d 4 plus d, and 5 plus c and 6 plus f. It's it's the result. Okay, now some also they have some properties like commutative properties. Means addition have commutative property like a plus b is equal to b plus a. Also associative property, that means a plus b plus c equal to a plus b plus c. These properties hold for the matrices. Okay, now matrix multiplication. What is matrix multiplication? Now you can see, if A is a matrix of order m cross n and B is a matrix of order p cross q, then multiplication is possible if this n and p are equal. It's not necessary that m and q are what, but n and p must be equal, then you can multiply these two matrices. Okay, now here you can see m multiplication. This is m dot n, means matrix multiplication is possible if number of column of A, this is the column, order of n means the order of column, that is number of column, and is equal to row of B, that means this is B, second matrix, his row is P, so n and np are equal, then the matrix multiplication is possible. So this is the first result. And second result is the order of matrix which is obtained by after multiplication, this will be this, means this will be vanished and m and q will be the next order. For example, you can take an example like A is a matrix of order 2 cos 3, which is 1 2 3 4 5 6, and B is another matrix which is 3 6 4 7 5 8, which is 3 cos 2. Now you can see this 3 and 3 are equal, so that's why you can multiply this. And how can you multiply this? The properties of multiplication is this first row is multiplied, this is first column, that means 1 with 3, there is 3, plus 2 with 4 is 8, 3 and 5 15, so plus 15. This is first element of the multiplication matrix. Also this with this, that is first row with second column, so 1 6 6, 2 7 14, 3 8 24, so this is the second element. And similarly this with this with this. Okay, and 3 plus 8 plus 15 is 16, 6 plus 14 plus 24 is 44, 12 plus 20 plus 30 is 62, and 24 plus 35 plus 48 is equal to 87. And this is our actual result. Now you can take some more example and you can do your own, so it's for your homework. Next, type of matrix. First of all, row matrix. What is row matrix? If in a matrix there is only one row, okay, and it's not necessary that there is some two column, three column, it doesn't matter how many column can be possible, but the row is one. Since this is the row, so row is one, so that's the row matrix. Column matrix, one column, so column matrix is it is not necessary how much column. So also an example 1 2 3, yes, this is also a column matrix. Okay, null matrix. If In a matrix, all the elements are null. That is 0. It's called null matrix. Square matrix. Square means, you know what is the square? If the order is in that is number of row and number of column are same, that is 3 cross 3 matrix, 4 cross 4 matrix, 5 cross 5 matrix, and similarly n cross n matrix are called square matrix. Okay, it's okay. Now, and also I is the identity matrix and A is another matrix. So A dot I dot A is equal to A. And if you don't know what is the identity matrix, then identity matrix is, yes, this is the identity matrix. If, and before understand, actually it is here, okay, and it is the right position of this point, because you don't know what is identity matrix, and after identity matrix you can go for that point. Now, scalar matrix. What is scalar matrix? If in a matrix all the elements 0 and without the principal diagonal, and the principal diagonal element are same, if the diagonal element are same, then it's called scalar matrix. And only, and you know, if only diagonal element are present, it's called diagonal matrix. And scalar matrix is a special case of diagonal matrix. It's okay. And this is a like A000 A00 A, also similarly 2000 This is the example of diagonal matrix, sorry, scalar matrix. And identity matrix is special case of scalar matrix where the diagonal element are 1. It's called the identity matrix. And if it is identity matrix, it is denoted by I. And here you can see A into identity matrix. That means any matrix, if it's multiplied with the identity matrix, then it's same. It's that doesn't change. Okay, now it was the first lecture, and I think you understand what I actually want to say today. And if I revise, then introduction of matrix multiplication, addition, and some example of the matrix was today's lectures. So bye, I'll see you in the next class of the matrix. Okay, bye.